All right. Hello there, ladies and gentlemen, boys and girls. Welcome to VUX World on the build up to the Voice and AI Summit. If you were at the Voice Summit last year, hopefully you would have seen the VUX World stage. Hopefully you participated in the VUX World stage. This year, we are back again at the Voice and AI Summit, and we will be doing another stage full of epic content. We have a whole host of amazing companies there with lots of case studies from enterprises who are implementing conversational AI, generative AI, the whole nine yards. So I hope you will be at the Voice and AI Summit. If you are not, if you have not got your ticket, go to voiceand.ai and you can find out more about the agenda. You can see what's going down and you can get your tickets there. So please do that, and we'll look forward to seeing you in September from the 5th to the 7th. Our day is going to be on the 6th, and it's going to be absolutely amazing. So there you go. Next, I'd like to give a shout out to Tidio for sponsoring the VUX World podcast. Tidio is a customer experience platform geared more towards kind of like small to medium sized online businesses. If you think about the retailers and e-commerce platforms and stores that are out there, Tidio is what you want to be looking at if you are looking to enhance your customer experience and maybe automate some of those kind of routine questions that your customers might have. It's already got out of the box the ability to answer things like product availability, shipping questions, order status, returns, all that kind of stuff comes out of the box. And the track record of Tidio is that it's answering 4 out of 5 customer questions successfully. So if you want to increase sales with the personalized shopping experiences and you want to dip your toe into the world of AI, then you should check out Tidio. And if you do that by visiting tidio.com/VUX, then you will save 20% if you were to go ahead and deploy that on your e-commerce website. That is tidio.com/VUX. Tidio.com/VUX. Thank you to the team at Tidio for sponsoring VUX World. Now, our guest today is an incredibly knowledgeable and very kind of how can I describe it? Someone who's been doing this stuff for a long time, and so much so that has actually created one of the most popular open source chatbot frameworks, Deep Pavlov, is Mikhail Burstev, and he has got an immense world of experience. He's currently a fellow at Landau AI. He's the founder of Deep Pavlov, as I mentioned. He's also the chief science officer at a stealth startup. So we don't quite know what's going on there. It's a little bit cryptic. Whether we'll get any insight into that during this conversation, I don't know. But Mikhail has a whole host of experience that I cannot wait to dive into right now. Mikhail, welcome to VUX World, my friend.
Hello, everyone. Hello, Kane. It's just a pleasure and honor to be on your podcast. And thank you for your kind words introducing me.
No problem. No problem. The pleasure is all mine. Really appreciate you spending some time with us. So, as I mentioned in the brief intro there, you have a wealth of experience in this space. Incredibly smart guy. Tell us where it kind of all began with you. Like, were you working with AI before Deep Pavlov? Like, where did the interest in AI come from?
So first of all, it all started with my academic interest in building system which can learn on their own, actually. And so at some point of time, maybe it was 2015, I understand that today to do something really impactful, you need to combine like some machine learning, deep learning techniques like reinforcement learning with conversational systems, because usually if you apply reinforcement learning to games, it's not a real tasks. It's more like toy problems. But if you want to apply AI to real problems, you might think first of all about robotics, but it's hard to get data. And then I understood that actually the sweet spot here is conversational AI, because you have a lot of live interactions with the real humans, and they are how complex as the real world. So they have a very complicated behavior, unpredictable, and building a system which will learn from humans, it should be amazing. We are still not there yet, but I think that we are going in the right direction. So this was a start for my interest in conversational AI. And also, first of all, I understood that we need a data, we need to build technology which will be useful. So we started this Deep Pavlov open source conversational AI framework. And already at this moment, there were many attempts by large companies building their personal AI assistants. So the idea was, can we build something like operating system for personal AI assistant, like conversational personal AI assistant? And we had a lot of examples like Siri, like Google Assistant, and Amazon Alexa, and Microsoft Cortana. And actually, on the other hand, I had a background in AI and thinking about different concepts of how we can build smart systems. For example, Marvin Minsky's theory of society of mind, that we should create something like multi-agent, that human brain is like society of smart cognitive agents interacting with each other, solving problems. And then at that moment, I've seen a paper by Microsoft describing like major architecture of Cortana. And you see all these like different skills carry over from one skill to another. And so basic pipeline for like traditional personal assistants today. So we decided that we need to implement this as a conversational AI framework, so everyone can take and, I don't know, deploy its own Amazon Alexa or Microsoft Cortana. So this is how we started Deep Pavlov.
Nice. And at the time, what year was this?
So we started this project, I think, in first ideas was about around 2015, 2016, but we actually started this like repo on 2017.
Okay, yeah. So that was right when Amazon Alexa was really starting to take off, and Cortana was releasing smart speakers and all that kind of stuff.
Yes.
And so was that the kind of like the main sort of goal, was that because the way that they're constructed is that they are assistants, bots, if you like, that perform very specific functions that all kind of sit behind this kind of orchestration piece, which then receives the utterance from the user and then determines like which one of these sub bots is the one that needs to respond. Was that the primary goal of starting Deep Pavlov, was to do that orchestration piece, was it?
So we actually we had not recognized clearly how which part of this stack we should build. So we started actually first on the lower part, so to provide some deep learning models for building like agents or skills. And then as a next step, we added this orchestration part, which we call DP agent, Deep Pavlov agent, which sits on top and then manages all this, orchestrates all these skills. So right now we have like two major parts in our framework. The first one, which is Deep Pavlov library, which is mainly something which allows you to build pipelines out of NLP models, like combining like named entity recognition, intent recognition, and some generative models, plugging in Hugging Face or some other models into your pipeline. And this part is mainly on like skills level, so you can provide some specific task on this level and build specific systems, maybe some of them with like scripted dialogues. But then another part, it's just orchestration, when you have some specific workspace for all your skills to send data to each other and to orchestrate and all your components of your system, like integrating. For example, you can have some pre-processing, like extracting some data, putting them in a like shared workspace, and then run some skills some conversational agents which will then access this shared workspace, read data they need, and then generated their responses. And then you have some kind of response selection, guardrails to understand which response is the best match for the specific context of the dialogue.
Right, interesting. And so would I be correct in assuming then that the Deep Pavlov as a framework is a combination of something a bit like a RASA, where you have some degree of dialogue management and control over conversations, but then also is, I'm trying to think of a comparable now, which is essentially like an environment where you can pull in any kind of models that you need to, whether that's through Hugging Face or whether it's through OpenAI or whether it's through Dialogflow or whatever, any kind of model that you need to, you kind of pull in and then you can utilize that, or different models within different kind of like use cases within the same framework. Is that, am I understanding that correctly?
Yes. So this Deep Pavlov agent, it's mainly orchestrator, which integrates all these different bots via APIs. So you can have one skill made with a RASA, another skill made with a Deep Pavlov, then another skill built, I don't know, in Microsoft bot framework on Dialog or Dialogflow. And then you can integrate them and switch between them on the fly and send data between them.
Right. Okay, I'm with you. Yeah. How do you kind of, or is there a requirement for? You mentioned the switch between skills. I always envision like you've got certain agents that perform certain functions that are kind of like defined, if you like, and then you would imagine that, let's say for example somebody wants to do something like change their address with their insurance company, they go into that skill, they complete that task, maybe they have another follow-up task which is, okay, now that I've changed my address I also want to add another car onto my insurance, or that will take it to a different kind of agent. But what you mentioned there, switching between them, do you find that that's a common practice, which is that when people are in the middle of one activity with one agent, they need to be able to move into a different agent? Is it a case of like the orchestration layer gives you the ability to bounce along these different agents and keep the context so you can get back to where you were coming from and all that kind of stuff? Or is it a case of when someone's fulfilled one function within one agent, they're then passed on to another at the relevant time? Does that make sense?
So as it actually, it's a matter of implementation of this skill selector part of your system. So you can either like delegate all control to your specific agent and wait until it has finished its like performing some function towards specific goal, and then like switching to another agent. Or you may try to like orchestrate it on the fly, so constantly monitoring context. And if you see that a user switched from one domain to another, maybe you would need like to, I don't know, save this current state for one specific skill and then run another skill related to the context the user switched to.
Right, I'm with you. And how do you kind of? We're getting to a place where I think businesses are beginning to get to this point where they understand the value of having their kind of assistants set up in that kind of way, where you've got specific agents that deliver specific capabilities, but then you've got this kind of like layer on top that kind of coordinates them all. You know, that's how kind of Alexa and Cortana was working, as you said. And as businesses get more and more skills, more and more content across a broader breadth of use cases, then having that single entry point becomes kind of important. What are the sort of like main things to consider when doing that? You know, let's say that one company has a chatbot with nuance and they've built another something or other with Deep Pavlov, and they're looking to try and integrate and get some synergy between it all. Like, what are the things that they will need to consider or things that they'll need to do in order to kind of make that happen successfully?
I think first of all, it's very important. We also see like many examples when companies have already many different bots built by different parts of the company, because usually you have something like from you have support function, you have sales function, you have like different functions related to your product, and you like different departments might set up their own bots. But then like user experience might be not very coherent because they are like developed independently and so on. And so in this case, I think that it's like good practice to set up something like some team in charge of integrating all these activities into one system, and these like team or person will be responsible for understanding like the whole user experience, then interacting with all the conversational systems of a specific company, and it will set up like scenarios for these skill selections. So like and then also warp this skill selection in some, I don't know, specific user experience, like making it holistic for the user. And then of course like these teams should then communicate with all the developers of the specific systems. So I think that it's important that specific agents should be developed by the people who are solving particular problems. So this is why I think that actually there should be some separation between the people who is doing this integration and people who are doing agents, which are like more focused on specific tasks and specific features of the products, because they feel better all the pains of the users and they can better implement all what they need from these parts. And but then all these bots, they should have some specific standardization for how to exchange data, and maybe their deployment can be optimized, because if they, I don't know, run some services twice, so that you might have one dialogue, but then different systems will pre-process it twice with like, I don't know, same named entity recognition. But if you have like one entry point, then you can only pre-process it once, and then all the downstream bots can then read this information and use it to produce an answer.
And one of the challenges that Amazon Alexa had was that it was doing a lot of stuff like first party stuff, play music, set timers, set me an alarm, do all that kind of stuff. But then it also had this kind of developer ecosystem where you could build skills for it, which are these like third party applications. And one of the biggest stumbling blocks of that platform, if you want to call it that, was Amazon didn't quite figure out a way to figure out what skills were the right skills for a given request from a user. Whether that was a case of not being able to route it correctly, or whether it was a case of not having enough understanding of what those skills capabilities were, I don't know. But I'm thinking of, like, let's say as enterprises start to deploy more and more agents, you've got generative AI agents in the mix, you've got kind of more intent-based, deterministic kind of agents that all start to do different things. One of them is working with this business division on sales and lead generation, another one's working on support, another one's working on something else. How do you sort of like make sure or ensure against the kind of like the front end not knowing which agent to send things to, for want of a better phrase? How do you make sure that the request goes to the right agent is the question, I suppose.
I think that that's a very, very important question. And this is actually why I think that Amazon was not very successful in switching between skills on the fly, and still you would need to use all these invocation words like names of the skills and stuff like that. But I think that right now we have a hope that we might solve this problem with the large language models, because the problem here with this orchestration is just in like having very good common sense understanding of the current context. And before large language models, we just had no technology to have good understanding. So we were able to train model to understand some intents, but still, even if you can predict intent for some specific utterance, I don't know, for some specific turn in your dialogue, you still, it's very hard to place it in the context, but context matters a lot here. So what skill should be called? But I think that right now, large language models will allow us to solve this problem because they have a very good understanding of the context. So, here is like a clear solution that you implement these warper or skill selector part with the LLM. And then what you need just to describe functions for specific skills, just in natural language, what this particular agent is doing for your customer or inside your system. And then ask your skill selector, LLM selector, you set up correct prompt to to direct user to the correct skill. This is how I think these can be solved, because the problem which we had like year ago was that every skill it can has good understanding inside some domain. So it can understand what user wants if it's related to some particular narrow domain. But if user just step out of this domain, then the system cannot understand that the user is already out of this domain. But I think that large language models, they can understand these situations and then they can handle it.
Interesting. So let me see if I'm understanding this correctly. So what you're saying there is that if you were to describe in plain English the features that each of your agents fulfills, you would roll that up into a prompt, pass in the user utterance, and then you would construct a prompt basically akin to something like, this is a customer talking to this bot in this kind of customer support or lead generation context. We have these agents that do these things. Which one is the best one to delegate it to, get the answer, and use that to then make the decision? Am I understanding that correctly?
Yeah. And also on top of them, to improve quality, you can use traditional intent recognition. So it's like that you have these, what you have just described, as well as some like ranking of all your options provided by your model. And I think that combination of two will give you like best quality which you can obtain today.
Right, I'm with you. So it's almost like it's almost like when you have, so some organizations, when they begin with contact center, call center automation, some will begin from the point of view of build an agent that solves a problem, and they'll put it behind the IVR system. So you press 1, press 2, press 3, and then you're talking to the bot, right? Others will approach it from the point of view of, we've lost Mikhail. He's back again. Are you back? Good to go. So what I was saying there is that some contact centers, for example, if they're going to launch, could be either chat or voice, the kind of place to start is either they'll create an agent that solves a specific problem. So you'll go to the IVR, you'll press 1 for this, press 2 for that, and then press 3, and then you talk to the agent. Others, though, and then what they'll do is then they'll create one agent, then another agent, then another until eventually every item on your IVR goes to an agent, and then they'll put a wrapper on top of that, which is just tell me what you want, and I'll put you right through.
Yeah.
The other opposite way of doing it is that you begin with the routing, intent-based routing. Tell me what you want, and I'll route you to the right live agent. And then over time, we'll then supplement those live agents with automated agents, and therefore we achieve the same result. We just do it a slightly different way. What you're describing there here really is almost a version of that, isn't it? Where instead of routing to the live agent based on the intent, really you're just routing to a separate automated agent based
Yeah.
on the intent of the customer. Is that right?
Yes.
Yeah. Okay, that's interesting. What are some of the...
And not only at the beginning of the dialogue, it also supports all the dialogue. So when one agent done its function, then these orchestrator can ask user, for example, maybe you want to have, as you've said, maybe you want to have an insurance, maybe you have another car, and do you need insurance for another car? Or maybe do you want to travel and we can provide you with a travel insurance? And and then if user agrees, then you can route it to the travel agent for creating travel insurance.
Yeah, that makes sense. And so in that instance, you basically, one skill comes to the end of its conversation, and then the orchestration layer comes back in and then takes over with it. It knows the context of the conversation, so it'll then just re-prompt you or prompt you and say, what do you want to do next, or do you want to try this because that's related to this or whatever. What about switching within the context of an agent? So I'm in the middle of having this conversation, I decide that that's not what I want to do anymore, and in fact I want to do something else. Or perhaps an example of that would be, so we're working with a government organization right now, and you can call up. Your bin outside hasn't been collected, so you'll call up. You say, "I want to report my missed bin collection." So that conversation is one agent that's having a conversation. That's fine. Sometimes people will end up in that conversation and they'll say, "Hey, you were supposed to pick my fridge freezer up yesterday. You didn't pick it up." Now that's a paid for service. It's a different thing. It's a different agent. So within that conversation, when that is picked up, we'll need to then send that into another agent. So do you recommend doing that at the intent level within each individual agent, and just you have to basically then be, from a design perspective, recognize that at this point in the conversation they might want to switch into this agent over there? Or does the orchestration layer play a role somehow at the agent level, where when it picks up an intent that's not destined for that agent, it then takes over and makes the connection? Does that make sense?
Yeah, I think that solution with orchestration is much more scalable, because if you have many components and then you add more and more different agents, different skills, different functions, then if you have this direct routing from one agent directly to another, you will need to update these routing tables, and then so I think it's more complicated in terms of engineering. But if you have just one point where you have registry of all your available skills, and you have a function of monitoring context, then you can do it better. And then it should be cheaper as well, because if you run agent, and when you have orchestration, you can have one smart orchestrator and pay for inference or for the large language model, and then you can have not that smart skills, which might be much more cheaper and run on your own infrastructure, no large language models, something rule-based. But if you want to switch from one skill to another, then you need better understanding inside every skill, every agent. And in this case, to get this understanding, you will need to run LLMs for every agent, which will be costly.
Right. So are you saying then that the way to, from architecturally, the way to do this is that the orchestrator agent that is handling that initial input, let's say that it determines that this agent is the right agent to solve this problem, are you saying that then you won't actually just kind of hand off into that agent? What you would do is you would keep the orchestration layer always processing what's coming in, and then sending that request into the individual agent level, and then bringing it back up to the orchestration level. Is that what you're saying?
Yes. So actually, we provide maybe we can say this orchestrator is a proxy. So it fully isolates user from the skill. So all the input and output from specific skill goes through the orchestrator. So after some specific skill or specific bot produced its own answer, first of all, this answer goes to the orchestration, and then orchestrator decides if this response appropriate or not. Maybe it should be guardrailed, or maybe it should be post-processed. For example, some names I added, I don't know, and only then it goes to the user. So this orchestration layer is constantly monitoring what is going on, and decides if, for example, we need to switch to another skill.
Right. I'm with you. What are some of the things that you've seen go wrong when people try and do that kind of orchestration piece?
Actually, we had not that much experience with this yet. So we're just starting to experiment. So I cannot share with you nothing in terms of, I mean, nothing consistent or reproducing, because you see right now we have these explosion of stuff like auto GPT and agents and so on. And basically, what we are talking about in our DP agent architecture is not that experimental, because in auto GPT you can generate plans and you can generate agents on the fly and then run them. Here, of course, for this automatic generation, you have very low reliability with the current models. So it can usually produce errors and cannot call properly some functions. What we propose is that it should be much more robust, because every specific skill it's developed by developers to solve specific problem, and we are solving only this orchestration part, which requires broad understanding. But all the fine-grained details which are required for specific requests, they might be rule-based or maybe recognized by specifically trained models, which has much better quality than large language models. Because right now, what we see that if we test large language models for traditional NLP tasks, like entailment recognition or intent classification or named entity recognition, they actually had performance 20, maybe 15% worse than specific models for these tasks, which means that LLMs, they are very good for common sense understanding of some context in general sense, but they are not as good for targeting specific information inside natural language input. And so to have a system with a good quality of responses, you need to combine both, LLMs to understand overall context and specific models to dig in to specific domain and have very good understanding inside the domain. So LLM might have no precise understanding what should be done in some specific situation, like related to car insurance. But it perfectly understands that client is talking about car insurance right now. And then it just hands on to specific model.
That's so interesting. So I do want to just reiterate that to make sure that I've understood it, and also it's worth reiterating. So what you're saying there is the studies that you've done around utilizing large language models for intent classification and entity extraction, the large language models are performing worse than a specifically tuned classifier for that specific task. Is that correct?
Yeah, sure. Even more, actually, we can find that if we task LLM with producing question answering over text, even if we can put all this text inside the context, so we don't need any vector databases, we don't need retrieval. So we have all the information in the text, which is in the context of the model, and we ask question regarding like this information. Still, it will have like performance about, I don't know, 55 some F1 measure in terms of response, but then specific model trained for this data set will have 75 F measure of response, which means that even if there is all information in the input, the model still can produce errors. So it's inherently like because large language models, they have trained for so many different tasks. They have like it's their inherent inability to focus narrowly on some specific task.
That's so interesting. What do you think then of, part of it is because of just the general hype around this topic, I think, and there's a lot of people who are whose interests are in kind of generating as much attention and revenue as possible in this period. But what do you think then of some of the claims that you see and hear about? Because I see and hear a lot of large language models are better at understanding, they're better at classification, they're better at intent recognition. And although we haven't necessarily used it for that specific stuff internally, we do tend to find that, like, for certain specific things that are of high consequence, like debt collection and government and stuff like that we do a lot of work with, then the more deterministic models tend to perform better. But even just in the studio of playing around and feeding it sample utterances, this is not skilled like data. This is just qualitative observations, essentially. Put some example utterances in and having it try and extract entities. I've found that it's decent enough, but some obvious ones you would expect it misses. So what do you think then of some of the information and claims that are out there regarding how good these are at specifically classification and intent recognition? Because there's quite a bit of it out there.
Yeah, I think that actually what we have here is an example for this Gartner hype cycle. Then first we have these inflated expectations, and but you see, everyone was just mind blown because no one expected that these ChatGPT will produce such a good common sense understanding, such good open domain dialogue. Because, for example, Amazon Alexa Challenge, it was like the whole competition targeted for open domain dialogue. And no one team, like every year, people from the 10 universities try to solve this problem. No one was able to address this to this extent as ChatGPT did. And we see that, wow, right now we have like the model with this almost human-like common sense, and it can pass some, I don't know, exams, tests, and it can switch topics, it can mimic different styles, it can provide you with a very good advice. And so it was great for creating quick demos, just to write down clever prompt and you have almost functioning system. It just You have input data, some natural language dialogue, and then you have output JSON, which is like parsed from this dialogue data. I think that it was amazing. But then people started to study it more carefully, compare with the existing systems, and now we see more and more evidence and more data produced by our team, as well as by many other research teams in the world, that for specific problems like intent classification, question answering for specific domains over the text, named entity recognition, they are pretty good. LLMs pretty good, but they are worse than specific models, which means that we need just to combine this technology, because I think that what we had before, all these BERT-based, Roberta-based models and LLMs, they are just complement each other very nicely, and we should use both. LLMs are pricey, but they has very good understanding of text in general, and they can summarize very well. But on the other hand, we have very good models for named entity recognition, which are much better than LLMs in terms of quality.
Interesting. So could you provide an example, even if it's a hypothetical one, of a kind of a setup for a conversational agent that utilizes the best of both worlds? Let's give it a hypothetical example of I don't know, the insurance example that we were given there. It's an insurance company. They want to provide the ability for people to get a quote and then decide if they want to take out the policy, and then actually take out the policy, all part of a conversation. Could you give us an example of where you think a large language model would fare better, and then also where like a more traditional NLP model would perform better in that kind of context? Just trying to understand how the best of both worlds kind of plays out in your understanding.
So certainly then you have like some incoming client, and you need some onboarding, some understanding what is the problem of the client, or what the client wants. First, you should start with this large language model. For example, a person wants to understand what are prices for different like insurance products for cars. And you can understand this intent with a large language model, and then switch to, I don't know, like a sales agent, which can then, this sales agent will use like named entity recognition to recognize name of the person, or all the requests about price, numbers, dates, like time periods. And certainly you can do this actually in parallel. You can try to parse them with a large language model as well with a specialized model, like something like assembling them together to get even better quality. And then this specialized agent, for example, can find the best product for the client, and then hand it back to the large language model, to this orchestrator, like this warping model, and then it will switch to the particular agent, which will go through the steps for creating contract, for filling in specific details and stuff like that. And in this, the specific agent will have its own vocabulary of entities, which is relevant for filling contract, and it will have specific clarifying questions, which are usually arise. Maybe it will have its specific FAQ related to like filling in contract, because FAQs for selecting product and for filling in like insurance contract, they will be different. And if you have understanding that you are currently in one or in another situation, you just improve quality of your responses, because you know that now you need to consider only specific subset of answers, and these are different.
Yeah, that makes sense. Yeah, so it's large language models for the kind of broad understanding to figure out the situation the user's in, more traditional classifiers for delivering specific features, delivering against specific needs, and then rolling back to the orchestrator, the large language model for.
Yeah.
In that instance, would that be kind of like you get to the end of that initial conversation and then you hand it back over to the orchestrator? Would that be a prompt to a large language model internally, basically, which is not seen by the user, which is this customer's just been through this situation, this is their situation now, what should they do next, sort of thing? Is that what you're thinking?
Yeah, this is totally makes sense, because I think also that we can provide like maybe a specific like evaluating or guardrailing LLM, which just performs sanity check if this response appropriate for the current context, and if the task is already finished. And then we can have like a talk between different models and natural language behind the scenes. It's totally makes sense, and I think this will be the next step of the technology. So we will have something like many agents coordinating behind the scenes. Maybe some models, specific models, will ask clarification from other models if they have not clear understanding what is happening, or if they need some data.
So if you follow that thread where you have multiple assistants, multiple agents within the context of a given company performing lots of different tasks. An example I gave previously to someone was, let's imagine that you're a bank and someone comes to your assistant and they say, I've lost my bank card, I was on the train, and I think I've left my bag on the train. Now, the assistant in that instance would say, okay, the orchestrator layer, using a large language model of some degree, knows, okay, this sounds like a lost card. Let's invoke that agent to sort this lost card out. So that agent will say, okay, let's freeze the current card, let's sort that out, and then let's order you a new card and all that kind of stuff. But then if you go one step beyond just an organization having lots of agents, and you go towards a place where lots of other organizations that also have their own agents that are able to interoperate between each other, potentially at very little effort, you could then say to the large language model that's orchestrating this process, okay, the account's been frozen and the new card's on its way, but still left over is the fact that there's a bag lost on a train. And if the language model then knows, okay, there's a bag lost on a train, what bots can I reach out to that know or can talk to train operator bots? So then potentially you could kick off something which would be akin to the creation of a new process just for that one customer, which is, let's go and clarify with the customer what train line it was. Oh, it was NLER. Okay, now let's figure out what time it was and what date it was. And now let's go and talk to the NLER bot and say, on this train, on this time, on this day, was there a bag left behind? Oh, yes, there was. And then let's make a connection between the person and the train company's bot for them to then retrieve their bag. Now, that could potentially be orchestrated without needing to be hard coded, providing there is an open, interoperable standard that these models and orchestration layers can kind of plug into. Do you think that that's kind of, it sounds feasible, but do you think that's actually where we'll end up, which is that once we've got through solving the problem of orchestrating multiple agents within a given organization, that actually we can start orchestrating multiple agents across multiple organizations to then enable those kind of use cases?
Yeah, actually, I'm totally with you on that. And but I think that I will explain how I think this scenario should work a little bit different. But in general, I think it's totally feasible. And actually, when even before we created our first repository on GitHub for Deep Pavlov, my thoughts were about things which you described. I thought that if we will be able to create personal assistants which understand human very well, understand natural language very well, then these personal assistants might serve as a proxy for the human user and as a proxy for organizations. And then in this case, it's when you, I think that it's like a qualitative jump in technology. When you have something which allows you to understand natural language in different components of your system, then you can provide this additional layer of like interoperability, when different components can talk to each other in natural language. And then in this case, you don't need to create like hardwired, like manually created communication links between agents. You can just create a medium where they can find each other depending on the task. And then because they can communicate in natural language, then they can like settle protocol how they exchange data and how they exchange information about some specific task. And it's amazing because then you can like add more agents, change what's inside, but still they will be able to be integrated by themselves into the system. And I think that in your example, you say that this bank agent can connect to this railway service. But I think that in this case, it should be personal agent, not bank agent, because bank agent should handle everything which is related to bank. But if you have personal agent, then this personal agent can route your request to the railway agent, and the railway agent will ask you all the details. And because this railway agent it actually knows about everything about trains, about schedule, and maybe if it even knows your route, and if you just provides like your ID that it was your, it can identify train and then can send someone to check you for your bag.
Yeah, I definitely agree with that. So the challenge with that though is that Amazon Alexa had the opportunity to do that, had the opportunity to be the personal assistant that could connect all these dots. And, you know, lots of people still use Alexa, but far less people are developing skills for it, for example. So it seems as though like the moment might have passed. It's not that it won't come back again, and if it implements, you know, more large language model based understanding and you know becomes more useful in other domains, then fair enough. But it seems as though like for the time being, at least as far as people's attention, Alexa's kind of died down a bit. But OpenAI and ChatGPT are definitely, as you said, going through that hype cycle. Would you envisage that personal assistant? Because for me, looking at OpenAI, they have the beginnings of that personal assistant. They're trialing plugins through ChatGPT. They're trialing web scraping through ChatGPT. You know, so it's kind of like it's getting itself into a position where it's trying to lay some foundations that would enable that future to kind of come about. Do you think that's the kind of game plan for OpenAI, is to ultimately create this personal assistant, or do you think they're just kind of experimenting with various different things as because they can, essentially?
I don't know. I think that for personal assistant, you should have two different parts. The first part is technology for very good understanding of intents and context and everything which is happening right now. And on the other hand, you should have like a lot of specific data about this user, because the more data you have about the user, the better predictions you can make and the better service you can provide. And OpenAI has a lot of technology on side of understanding, but it is not yet have good access to user data. But on the other hand, I think that this personal assistant thing is very, very disruptive. We don't know when. I think that inevitably it will be created by one company or another. But when it will be created, it will just totally change a lot of businesses. For example, it might just make all this web advertisement obsolete. So this is why I think that Google is the company which should have the highest pressure to do something like this. And actually, It has data. It has a lot of personal data about where you were for the last 10 years, what you have done. And also they had a pretty good, strong technology team, all the DeepMind and the Google Brain and stuff like that. So I think that in terms of potential, Google is much stronger to create something like this. Certainly, they have some legacy with the Google Assistant. Maybe it's harder for them to reinvent themselves, but they are. I think that they have like the most chances to create something like this.
But they have kind of had their fingers burnt a little bit with Google Assistant, haven't they? Like they've had to pull back and sunset kind of like conversational actions, which is the third party kind of component to it. So they've had a stab at creating that personal assistant, didn't quite go exactly how it was hoped. So like, do you think they will kind of try and have another bite of the cherry, or try and just build it all into kind of Google search?
I think that if they will not do this, some other company, I don't know, Microsoft or OpenAI, if they will do personal assistant on their own hand, then all the Google business will die.
Yeah.
This is my, I don't know when it will happen. Maybe in 5 years, maybe in 7 years, maybe in 2 years. I don't know, but it's definitely. I think that personal assistant, because it's so simple that the more data you have, the better quality of service you can give to your clients.
Yeah.
That's it. So if you have personal assistant, this personal assistant had as like the most data any one system can have about you. And so the first company which will create useful personal assistant will get most data, and when it will get most data, it will get even more better in terms of serving this. So it will be very hard to outcompete this company.
Interesting. Will that occur? Let's see. Cool. Well, I know we're a little bit past the time now, but thank you for sticking with us. So we do have another episode of this podcast with yourself, Mikhail, booked next week. So if you're tuning in right now, then Wednesday the 16th, we're going to do this again because we've touched on some stuff regarding large language models, which has been a very fascinating conversation. We're talking about large language models from the point of view of being an enabler and an orchestrator of wider and broader AI programs for businesses when they have multiple different agents doing different functions. We've spoke a little bit about the potential for large language models to enable that personal assistant that we've kind of all been wanting, since Amazon Alexa and Google Assistant and Siri, and they've all felt a little bit short of our expectations.
Yes, Apple is another competitor. I think it also has a lot of personal data and
definitely so much personal data. I mean, Siri should be the best assistant on the planet. It's just that it falls short of actually doing stuff. It's most of the questions I ask it these days, it sends me a web link. That's how it it seems to have gone back over. But to get to that kind of place where we've been discussing, which is this more personal assistant, and even some of the shortfalls that we've been mentioning here around large language models being less good at classification and entity extraction, there's room for it to improve, and part of that is the ability for it to retain memory, to have wider context and all that kind of stuff. And so Mikhail is thankfully going to join us again next week, and we're going to get into more detail around the specifics of where large language models need to improve and how for them to be ultimately effective as we believe them to be. So thank you, Mikhail, for joining us on this one, and we'll see you again next week.
Great pleasure. Thank you for inviting me. See you next week too.
See you next week. And for those of you who don't manage to tune in next week, I hope you all do. But if you're not convinced yet about giving Deep Pavlov a try, I'll be surprised if you're not convinced, because this conversation has been riveting, as I'm sure next week's will be. But you can try Deep Pavlov at deeppavlov.ai, deeppavlov.ai. Is there any other places or resources that you would direct people to, Mikhail, if they want to learn more?
No, this one is the best entry point.
Perfect. All right. Thank you again. And thank you all for tuning in. We'll see you next week on Wednesday.